Hello, everyone, and welcome to another episode of Connected Talks, a venture by Frames Alumni Association. Today, we have with us Mr. Siva. Before moving on to the interview, let me give a short introduction of our guest speaker for today. Mr. Siva completed his Bachelors in Electrical Engineering from the University of Mumbai in the year 2011 and completed his Masters in Systems and Control Engineering from Indian Institute of Technology, Bombay in the year 2013. Subsequently, he worked on the automation of testing and validation of semiconductor devices and sensors at Cypress Semiconductor Corporation. He is currently pursuing his Ph.D. in the University of Minnesota, Twin Cities, with a major in electrical engineering and a minor in computer science. His thesis research is at the intersection of statistical mechanics, biophysics, and mathematical modeling aimed towards studying proteins at the single molecule scale. So moving on to the interview, sir, my first question is, what programming languages you expect a student to be well versed with when he or she graduates?
Depends on the of work they plan to do. So I believe if you are familiar with MATLAB, that is good for career in control systems or signal processing, because most people I've seen pursue that career work with MATLAB, even in the industries. And they also have lots of toolboxes, relevant toolboxes there. And then if you talk about more of scientific computing or machine learning, I've seen more people use Python. And Python is fairly similar to MATLAB. I think you can do more things with Python compared to MATLAB, but they are somewhat similar. So I guess if you are well versed with one of those, you can translate them. And these are high-level languages. You might want to also work with lower-level language like C or C++, which I think.
If you're interested in a particular research domain and you want to contribute to it, how much time can we give to the literature survey, sir?
That's a hard question. I think I don't have an answer as to how many days or months to spend on that. So I've seen two approaches. I've been given different kinds of advice. One has been to take your time, as much time as you need, to thoroughly understand the area that you're working in, because it doesn't make sense to reinvent the wheel where you work on something for a few months and then find out, oh, there is a paper already describing exactly what you do. That doesn't contribute to the work. So, and in that approach, they say take as much time as you need to thoroughly exhaust everything. And then there is another school of thought where it's like a continuous process. So you just start reading papers, and then whatever ideas you have, please start trying to implement them. And then if you try a particular approach, look for papers trying to describe that. Make sure you are not doing something repetitive. You are trying to do something new, something useful. I guess it depends on what you like to do. You could take it in batches. You could read a couple of papers for a few weeks and then do your project and read more. So that might be one way to do it. But usually when you get into a research career, whether through industry or through a more traditional academic pathway, you usually get mentors or an advisor who is much more well versed with the field. They will give you some guidance as to how to go about this process. You can talk to your own professors or FCRIT.
How do you identify the right conference, as in when you want to present your research paper?
It depends on the field that you work in. So if you have to first of all identify what domain present your paper in. So sometimes it happens you do work on multiple domains in your research area, because problems don't come from one specific domain. You might have two different kinds of domains. So for example, the work we do in our lab is a mixture of systems modeling, just like a system identification and control systems, plus some biophysics. So depending on how the work turns out, we might choose to present it to one field or the other. So based on the field, sometimes you have to determine whether it is much more valuable to put your work in a journal or as a conference. In computer science, I've seen a lot of weight given to conferences. In electrical engineering, people respect journals more. You will get an idea once you do your literature survey where the most interesting papers are, and then your mentor or your advisor would give you some. And the other key thing is, if you're deciding on your own, one thing to look out for is the audience. You want to make sure that your work reaches the maximum number of relevant audiences. Your work helps somebody else do more work. That's the way it works.
According to you, pursuing masters right after graduation or pursuing 2 years after working in your core field, what would you suggest?
I can spin a story for either way. So I think there is no right or wrong answer. You have to kind of see what works best for you personally. And I think you can do it anytime in your life. So having said that, I can maybe give some advantages and disadvantages on both sides, but that's an opinion, of course. If you're going to go right into it after your undergraduate program, you will find that you might not have to read up undergrad work much because it is still fresh in your mind. So that's an advantage. You're still used to being a student. Once you start earning money and you have a regular paycheck, it might be difficult to go back to being a poor student. That matters. Later on in life, you might have a family of your own that you might have to support, or parents that you might have to support that might stop you from traveling far away. It's also a matter of time and place and luck where you end up. You might not be able to avail every opportunity you get because of other constraints. Maybe try to do it earlier in your life than later, but you still have your entire 20s. But don't let your age or where you are at stop you from pursuing what you want to do. I've seen people from all walks of life do a Ph.D. or a Master's. Master's is usually shorter, not 2 years. Ph.D. is a longer haul. Depending on what you work on and where you do it, it could be 3 to 6 or 7 years. There is an advantage to working for a few years to do your Master's. So I've seen some people tell me who have not worked before, they do get a little disillusioned in the sense that they're not sure what they want to do with their life, their career. But once they work for a little bit, they get a clearer picture of what they want to do. So they have more motivation to pursue whatever they choose. Because once you have to choose something in your master's, so that might help. That's a big advantage.
There are times when you don't get the expected results, and often it reaches its fag end, and especially when the research is something that you're really passionate about. So how do you motivate yourself?
So one thing that I think we don't get to see when we just read published research is the number of failures. You get to experience that when you do it yourself, but usually many things that you try do not work out. You have to be ready for that. So the way to get around that is it helps to have a mentor. That's one of the key things. That's why your Ph.D. program will pursue that, or even a master's program will get you an advisor. I think that's true for undergraduate work too. Once you do your final year project, you usually get an assigned faculty member. So they are there to guide you. So one of the key roles that they play is to tell you what not to try because they believe it will fail. Instead of you going and trying every single method and failing, kind of eliminate some branches in your trials, right? So that is one way to minimize that from happening. But then you just have to be ready for it. Just be mentally ready that out of 5 things you try, 4 of them would fail, or maybe 10 things you try, 9 of them would fail. That's another thing to keep in mind. Sometimes you might want to pursue research which is a little bit ambitious, in the sense that either it could be a large project, you hope to achieve a lot of things, or it could be a very novel project. Nobody has tried anything remotely close to that. Many a times we do research which is somewhat incremental. Most of the pathway would work and then you're adding a little bit. That's more likely to succeed. But if you're going to try something completely out of the blue, it might fail. So you have to keep that in mind. And what I've seen in our lab at least is we are given a couple of projects in your PhD program. So it's not just 1, 2 or 3, at least 3 minimum projects which are somewhat different. So if one branch ends up leading to nothing, no successful work, just say, okay, maybe I've tried for a year or 2, doesn't seem to lead anywhere. Let's put a break on that, try something else, work on the other projects and bring them to a completion. So those are the ways to mitigate, I guess. To summarize, it's like have a good mentor who eliminates some possible failures. Be ready for some failures to happen. That way you don't get demotivated, and then also work on multiple projects.
What message would you give to the students of FCRIT, sir?
Don't stress out too much. Don't worry about life too much. Things usually work out. Working hard on what you like. Find out something that you're passionate about. Work on that. You have a global pandemic going on during your program. I'm sure that adds a huge amount of stress in your life. But know that don't be so hard on yourself.
I would like to thank you for taking out time for this wonderful session. Thank you, Mr. Siva.